Good afternoon, Howard Wigg, Code Green, ThinkTech Hawaii. Do we have an interesting show this evening or this afternoon or what? You've been reading time after time after time about the Department of Education and the hot classrooms, and let's do something. Let's air condition those classrooms. What is DOE doing? Well, it turns out that they have hired two of the most distinguished designers, building designers in the state of Hawaii, in my unbiased opinion. Mr. Bill Brooks, architect with Ferraro Choi, and Mr. Charles Chaloeicheep of WSP Engineering, very, very, very expert in their field. And they are doing pilot projects on different school buildings to say, here is the real solution to achieving comfort and a higher quality of life for the students and for the teachers. Welcome, gentlemen. I'm very honored to have your presence here. So why don't we jump right in? We've got a whole lot of ground to cover. And Bill, why don't you give us an introduction about how a distinguished architect and distinguished engineer got involved with the public school system?
Well, thank you, Howard. Thanks for having us, number one. And actually, working for the schools is something that's been of interest to me for quite some time, and in particular the schools, because we feel that we have some good that we can do in that arena. Mm-hmm. We kind of feel that the public schools would benefit from people who have shared their vision a little bit more than some of the designers of the past. So that's how I got started.
I was brought into the Kohala project after spending some time in San Francisco, but moving here and recognizing the great opportunities that are available here for natural ventilation, or sometimes I like to call it passive cooling. And so I'm really excited to be part of this project to hopefully set a new example for future schools within the islands.
Yeah, I've been sort of bugging the Department of Education, but let's say gently nudging them towards passive design. And incidentally, passive, you know what? You're an architect, you define passive design better.
Well, passive design to me means a building that does most of the work for you before you introduce systems like lighting and air conditioning or ventilation into them. So I always consider it similar to having a black car and leaving it in a parking lot with the windows closed up, because that's how most of our buildings have been designed over the last 50 years. And then we come in and we have to put a lot of air conditioning in them and so on to make them comfortable. So our theory is to park a car in the shade of a tree and let the breeze go through it and have it be a nice structure to begin with.
Good analogy, yeah. And I might add that I have been all over the world, and I can attest that Hawaii has the most beautiful climate in the world. Why in the world don't we design our buildings to take advantage of that beautiful climate? And then there's many other quality of life and health benefits, but maybe we can get into those later.
Yes, those are all really interesting topics. Yeah.
So why don't you launch into what you're doing here?
Well, thank you. I thought it might be of interest first to just take a look at some of the projects that we've been doing recently with DOE, either DOE proper and then in particular one of the charter schools under DOE. And so I have some slides. This one is an image of the Waipahu Intermediate School cafeteria. And it was actually our very first project with the DOE, and it was actually DOE's very first LEED certified project. What you're looking at on the image are the thermal chimneys that are part of the design of this particular cafeteria. The roof is designed as a thermal chimney, so it's a cavity that heats up and draws air through it and then exhausts it at the top. And that allows stack ventilation to happen very easily on days when cross ventilation may not be as available as you'd like it to be.
And somehow I bring to mind, I think it was Newton's law that heat rises.
Yes, it's really that simple. Yeah. And the roof is the engine. You know, the roof creates the heat that creates the delta T that makes that air move.
And delta T is the difference between, in this case, say, the floor temperature and the roof temperature.
That's correct. Yep. That's correct. This is a view from the inside of that cafeteria that shows you also the clear stories that are used to bring indirect daylighting into the space. And of course, daylighting is a form of light that's much cooler than electric light, so that helps to keep the internal heat gain down as well.
And daylighting is a lot healthier, but let's get into that one
Proven to be
later.
much healthier, yes.
Yes.
Totally agree.
Yeah, and if I remember this project, this is a good solid 5-6 years old.
Yes.
And the cost, this was a LEED project also, and the cost was considerably more than would be the case. And I think maybe this, correct me if I'm wrong, this was kind of a test case, and because you had to experiment, the cost went up. But the cost of building LEED buildings has gone down ever since. Is that a correct assumption?
That can be generally true
Yeah.
depending upon the level of LEED. In this particular project, as you know, DOE sets their budgets long before sometimes they decide on how that money will be entirely spent. And so the decision to go LEED was a little bit late in the game. I think this project came in at about 10% higher than their budget, which wasn't too bad.
Not bad, yeah.
And of course, a lot of that had to do with escalation, not just the fact that we were doing passive design.
But I interrupted. If you could describe this cafeteria project some more, because you want to bring back the previous slide? Yeah.
Well, actually, here we're going into a second cafeteria
Oh,
project.
okay.
This one is even in an area that would be a little bit more of a challenge. This is in Lahaina, and this is the Lahaina High School cafeteria. And as you can see on the left-hand side, there are a lot of windows. They have astounding views, and it's a very hot area, as you know. But the DOE cafeterias are typically naturally conditioned, naturally ventilated, and this is no exception to that. And so we have a very high space with outlets for hot air at the top. And then this is the first project where we started using the large ceiling fans, which are very slow and quiet and very effective in moving air. And then the building is set up so that it cross-ventilates well at the same time. So this project was constructed and has been in use for about 3 years. And so far, we've heard only good reports. Everybody's comfortable, and it turns out to be a major hangout place for the kids because they love to gather here even in between the meal times.
Now that is testimony.
Yeah.
Yeah. And probably, if you consider the fact that you did not have to install an AC system with all the ducting and attendant work, you came in maybe right about on budget?
This project was actually slightly under budget. So again, our theory is that best practice doesn't necessarily have to cost more. It's maybe one of those things that people think it has to, but doesn't really work out that way typically.
I like that phrase, yeah.
Okay, and then moving on perhaps to the next slide, which looks like sky, but if you look down a little bit lower, if it's possible, there we go. This is the West Hawaii Explorations Academy. It's a kitty corner to the Kailua Airport at Keahole Point.
Ooh, hot area.
Very hot area.
Yeah.
But we designed these buildings as modular, which assisted in the phasing for the project. And there's very limited air conditioning in this entire project. All of these buildings are oriented for north-south exposure. They have areas for PV on the top, and only the computer labs are air conditioned. Everything else is naturally ventilated. If we go to the next slide, it'll show you the inside of their maker space where they do their STEM work. And again, we have the large ceiling fans. We have high clear stories that are facing the north. And we also have ridge vents, which aren't visible in this particular photo. But the general idea was to create large open spaces that were very conducive to natural ventilation, and also designed so that they don't allow heat from the sun to get into the building to begin with. So the insulation is quite good, for example.
Yeah, and then I see on the left, extreme shading. It looks like a big lanai.
Yes,
off to the
that's
left there. Yeah.
where they can sort of spill out and work on their projects outdoors. The next slide is a typical classroom, which is using the same sort of principles. It's just a little bit less open, but again, you have the tall, clear stories on the north side, the large ceiling fans, a large internal space, because we all know that having enough room for air to move upwards and actually exhaust itself is important in good passively designed buildings. But look at the kids here. Look at that kid in the foreground. He's wearing a jacket. And this is a typical, like probably an 85, 86 degree day in Kona, and these kids are all very comfortable. So we've heard good things from the principal, and things seem to be working out well.
And if there's any hot area of this entire state, it's that Kona area. It's surrounded by that black lava from a fairly recent lava flow.
Yes, that's right.
And that absorbs heat like mad and then radiates it, yeah.
Very hot, dry. In fact, the terrain is fire grass over Pahoehoe. So it's not exactly the kind of place where you'd think of being naturally ventilated.
Yeah,
per se.
yeah. And yeah, that kid wearing the jacket, that is real testimony.
Wonder what the CLO value, right, was there in terms of ash rate.
Wow.
And then I think I have one more slide of one other school. This is under construction, but it's intended to be open right about the end of the year. This is Stevenson Middle School, right below Lincoln Elementary and kind of across the street from Roosevelt High School. And this is a cross-section, an artist's rendering of a cross-section that is cut through their STEM makerspace. The school science faculty were very interested in having a double height space with a mezzanine so that visitors and competing schools could look down on the robotics competitions on either side of the space. But this room in particular is naturally ventilated, and it has daylighting tubes for daylighting, a lot of upper windows to let that hot air rise and escape, and also situated so that it does get limited cross ventilation at the same time. So we're really looking forward to this particular project. The next slide, and I think is the final slide of the examples, just shows the other side of the building where the more conventional classrooms are located. And we have a small, sort of a pilot green roof that you can see there on the left, and then a small PV array that's actually wired so that it serves certain outlets in each of the classrooms. So the idea is that the kids can get an idea about the energy is made here and it's used here, and that means more to them.
Is there a little mini meter or anything in each classroom so they can see how much electricity is going in?
I don't think it was metered separately. I can't remember, Charles. This predates your work with us.
Yeah, I don't think that those would be metered separately, but the PV arrays are typically metered at the inverter. So it gives an idea of how much you're generating, and then you have your main meter so you can get a feel for how much you're offsetting overall.
Yeah. And I might point out with PVs, number one, they're covering the roof, and number two, they're raised by, 3 or 4 inches off the roof surface?
Typically, yes.
And we won't go into the reasons for that, but what that does is create not only a shaded area, but a shaded area with the breeze going through. So it might be the case that that roof under there is less than ambient temperature. If it's 85 outside, it might be 83, 84 under that roof there. And then you have to ask yourself now, what kind of insulation does it take to keep that 84 degree outside heat from affecting the, say, 75 interior heat? Your delta T is 9. Yeah, there's going to be, and the engineer can correct me, virtually no heat transfer from outside to inside. Just another benefit of PVs. And I wanted to ask you about the green garden. Seems like it's green garden. Of course it's green. It seems to be exposed to the full sun. How do you keep that thing from wilting?
Well, we have a little water collection system right there so the kids can water on a daily basis. And the plants are actually not part of the roof structure. They're sort of a grid of small pots. So they have the ability to manipulate things so that but you know, we'll see how it goes, because the survival of that garden will depend a lot on how often the kids get out there and how enthusiastic they are about that part of the program.
And what happens in the summer when there's no kids there or whatever. Hopefully somebody takes those plants home. But on that cheery note, calls for our first break. Code Green, Howard Wigg, ThinkTech Hawaii, back in a minute.
Hi, I'm Chris Leatham, and I'd like to invite you to come and watch my show every Wednesday at 3. I'm interested in a variety of issues that have to do with politics and our local business economy. And I'd like to bring on guests who like to talk about everything from technology to social media to what we can be doing to improve our environment. And so I'd like to invite you every Wednesday at 3 to stay and watch my show here with ThinkTech Hawaii. and I'll see you there.
Aloha! How you doing? It's me, Angus McTech, wishing you to welcome and join us to see us on Hibachi Talk on ThinkTech Hawaii. Join my co-hosts, Gordo the Tech Czar and Andrew the Security Guy, every Friday from 1300 to 1345. We look forward to seeing you. We'll talk tech and we'll have some wee bit of fun. And remember, let your wing gang free wherever you be. Aloha!
Okay. Good afternoon again, Howard Wigg, ThinkTech Hawaii Code Green, distinguished guests, consultants to our public school system, Ferraro Choi, Bill Brooks, and Charles Chaloeicheep, WSP Engineering, two of, in my opinion, the finer designers in the state of Hawaii, honoring the public school system with some very, very innovative designs, which we've seen a whole sample of them. Now I believe we're going to go into one particular project.
Yes, that was
Yeah.
the idea, Howard. I thought it might be of interest to show your audience our most current project, which is at the Kohala High School over in Kapa'au on the Big Island. This is a Google image, and the large yellow square with the number 3 in it is the site out of the 4 that we studied where we decided to locate this new STEM science facility for the DOE. And by the way, I apologize for hogging all the talk. Charles is going to come in a little bit, in the, or a lot, I should say, in the last segment when we get into some detail about thermal comfort. Okay, if we move on to the next slide. This is just an overall site plan of the project. It consists of 4 separate buildings which have been oriented to capture the prevailing winds which come from the east in this particular site. On the upper left are a couple of general classrooms, and then stepping down this gently sloping site are 3 laboratory classrooms, a physical science, they're what they call natural resources, which is STEM, and the other one is, what's that third one? Well, there's a third. Biochemistry, thank you.
And before we go further, we might define for the audience STEM.
STEM is science, technology, engineering, and math, and it's sort of the new acronym that's not only part of the DOE system, but part of the K-12 system across the country.
Yeah, where we find that we're falling behind other nations, especially Asian nations, where we don't have as many kids coming up through these ranks. And the result is that a lot of our science and engineering oriented universities, especially the fine ones, are being more and more dominated by Asian kids from Asia, because they're the ones who really apply themselves. So this is, in my understanding, is an effort to get American kids up to snuff here, because these are the professions of the future.
Well, that's what I've heard as well, but I will say that if these kids that I've seen are any indicator, we're going to be very competitive very soon.
That's good
because
to hear.
I've never seen such interest on such a high level. The kids are really, really like to get their hands on things and get dirty and make things, and I think they're learning quite a bit in the same time.
Yeah.
What's nice about this one also is that the students are involved with some of the design reviews. And so they've been able to give us some feedback and give us some input on how they use the space. That's really helpful for us to make sure that it's designed not only for DOE and longevity, but to serve the students most importantly.
That's great. I call that boots on the ground type study. Yeah, a real world type study. Yeah, I'm glad to hear that.
In fact, the kids that we've had in our charrette sessions are just extremely engaged and very thoughtful in their comments. They haven't been dragged into these things. They come of their own will, and they contribute quite a bit.
Yeah.
And it's a great point of view to hear.
Yeah.
On this next image, let's see what we have. This is just a cross section through the site, and as the camera pulls away and you start to see the entire image, you can see that the 4 buildings are on a gently sloping site, and now you can also see the roof forms that we attempted, or that we have decided to use on this project, are gently curving forms, which are really great for daylighting, and tall on the one of the sides to again promote our natural ventilation concept. the school was very interested in an architecture that was both unique and yet had enough of the traditional finishes and so on the outside so that there was some connectivity with the campus and with the community history. So they're pretty excited about these new buildings.
Yeah, and it has a graceful, those curves are always more graceful
Yes.
than just plain old rectangles.
Well, one of our thoughts is that if you're in nice architecture, it can be more inspiring, and it'll get the kids to be more engaged in what they're doing.
Yeah, yeah. Yeah, that's a heck of a lot more inspiring than walking into this enclosed rectangle.
Right.
Yeah, it's having heat pour through it.
Yes.
Yeah.
That's
yeah.
our opinion as well. These are just some additional cross sections to give you a feel for what these buildings look like. We are just really excited that the construction on this project is slated to begin, I think, next fall. So we're just finishing up the design right now, and in fact, we're meeting with the school on December 9th to show them the final design, and then we'll be going to bid early next year.
And how about cost? Is there a huge additional cost for that curvy, tall building, or?
Well, once again, we haven't received hard bids yet, but at the moment we are under budget, according to 3 estimates that have been provided by our estimator. The next image will give you a little bit of a feel for the final school. This was actually produced in our office by one of our folks there, but now you can start to see the traditional colors and other aspects that'll make these buildings, I think, fit nicely with the existing campus. This is a shot showing the main entry as you come in, and then working down to the Natural Resources building on the far right.
So in terms of passive design, I think it's interesting that, we've opened it up on the north. Troy did a good job of protecting the space from the direct sun, which is, a killer in terms of thermal comfort. And we'll get into that later. And then we have all the openings on both sides with, the greater amount of openings on the leeward side. And so the wind can come through the space quite naturally. And then we also have those roof vents.
And is the higher side constituting a form of funnel, or you're funneling the air in and then sort of concentrating it? Is that the idea, or?
In this case, the prevailing breeze comes from the right and moves towards the left. So if anything, there would be a bit of a Bernoulli effect here, and it would actually pull, it would create a negative pressure right at that eave and help to actually pull the air through.
Okay,
But you can also see on the top of the roof, we have the standard gravity ventilators. So we've got a lot of ways for air to move through this building. Cross or stack or assisted, and we've got a fan. The whole, one of the sort of the cardinal rules of natural ventilation is to maintain a reasonable sensation of air movement across your body as you're in the space.
Precisely, because we're 98.6, and we don't exactly want a little envelope of 98.6 degrees forming right around us. Yeah.
That's a good way of putting it.
Yeah. Yeah.
And then the final slide shows the school from the east edge looking towards the west. And this is just sort of featuring another one of the important part of schools these days, which is to have a defined exterior area that's sort of multi-purpose. So they could come out here in the evening and they could gaze at stars with telescopes. They could set up a tent during the day and have an event. There's some seating at the far left here where they could have a theatrical production or a robotics competition. So it just gives them a lot of flexibility in how to use their buildings and their campus. And you couldn't have picked a more beautiful site. I mean, Kohala as an area is just stunning to be in, so it allows them to celebrate their environment as well.
Yeah, there's one thing I follow are the very wealthy people who are building off-grid homes where they're totally disconnected from the electrical grid. And these people have a lot of money. They can site anywhere they want. And some of them are siting right up in this neighborhood, way up in the north of the Big Island, because it's so green, so lush, so cool and quiet. Yeah. And we might add that about the site of this school. It's probably one of the more rural schools in the entire state.
It ranks right up there with, I would say, with Lanai. And maybe down in the Ka'u district and some of those, yeah. And one of the neatest things about working in these remote schools is that they tend to be very heavily immersed in tradition. Family members went to the schools. The kids all seem extremely well behaved. We've seen much less graffiti, if any. And I just wanted to touch on that point. One of the that you made about wealthier people that maybe moved to the Big Island. Excuse me. One of the interesting aspects of working on that island is that there are many, many people there who are already off the grid. And since the whole mindset about doing a project that's passive design, renewable energy, it's already entrenched over there, and so there's not any problem convincing people that that would be a good way to go.
And having confidence that they're going to having confidence that they're going to operate appropriately, right? A lot of times if you're introducing a new technology that maybe is a classic technology, it gets a little bit more challenging to guarantee the performance that that we can prove, that we can model.
Yeah. So Big Island's a really great place.
And I believe this school is sited a few hundred feet above sea level.
It's about 500 feet above sea level, and it's we'll have another slide in the next segment to show you a little bit about the microclimate there. But if you're familiar with the Kapa'au area at all, it's sort of right between the towns of Hawi and Kapa'au, almost right in the middle, maybe about 3 miles overall from the Upolu airport. Beautiful area.
And near to King Kamehameha's supposed birthplace, too.
Yes, that's right. Yeah, the Kohala area is very steeped in history, Hawaiian history.
Yeah. So when you're looking at the design of the buildings and those extreme overhangs, another facet of daylighting is not only lack of heat gain, which I assume you designed for, but lack of glare. You have a big glare coming through your window. Your instincts are to shut that curtain and keep it shut.
We do have some severe exposures to the east and west on this project. And what we've done is apply a solution that we used at the previous project, the West Hawaii Explorations Academy. Because that roof overhang for east and west, it's not going to do a big job when the low sun angles. So we've taken to the idea of using a Bermuda type shutter, which is hinged at the top and opens up maybe about 2 feet at the bottom. And the slats are positioned so that if you're in the room, you can actually look out and you can still have visibility, but it does a great job of totally shading the window. And we've got a shading study a little bit further down the pipe here that will show you that we're literally getting no direct sunlight into the space. In fact, our shading is so good that we're working with Charles to put in a couple of daylight tubes because it is having a little bit of impact on the district.
Sure.
Even though your occupants are kids with supposedly better vision than us senior types there. Yeah.
Sure. And I think it's great that Farrar Choi recognized that the shutters are external, right, versus what you were talking about, closing curtains, which does help with direct sun and glare, but doesn't quite stop that heat from getting into the space and possibly ruining your passive cooling design. So by having those shutters outside, it's the right thing to do in terms of glare, but it's also the right thing to do for thermal comfort.
And we need to take a break, but I will close by saying, in my rather extensive experience, once those curtains get closed, they stay closed, and all that beautiful design that you've prepared for just goes to waste. So on that cheery note, let's take our second break. ThinkTech Hawaii, Code Green, back in a minute.
Aloha, my name is Justine Espiritu, and I co-host Hawaii Farmers Series with Matthew Johnson of Oahu Fresh. We talk about Hawaii's local farmers and their supporters. In order to have a vibrant and sustainable local food system, farmers are always the foundation, but there's so many other people involved in the community that help support those farmers. So we bring those folks onto our show every Thursday at 4 p.m. We get their backstory, their history, find out a little more about them, and we find out why they love what they do and their perspective and their advice on how we can continue to have a dynamic and vibrant and sustainable local food system. So we broadcast live every Thursday at 4 p.m. And you can also catch us on ThinkTech's YouTube channel as well as Alelo 54. So we hope you tune in and join us. Thank you.
Good afternoon for the third time. Howard Wigg, Code Green, ThinkTech Hawaii. My distinguished guests, Bill Brooks from Ferraro Choi Architects, and Charles Chaloeicheep from WSP Engineers. Very fine people working to improve, and we're seeing on this program really actually truly improving some of Hawaii's public schools, and hopefully that's going to serve as a model for future design of the schools. And I'm really impressed that you're coming in not just on budget, but very often under budget for these beautifully designed schools. We can do away with all these rectangles around here.
We certainly agree, and there have probably been a few exceptions, but for the most part, the budgets are working out well, which is good because oftentimes they're set before we get there, and no one quite knows where they're going to be going with that money. So,
yeah, and I've worked in this field for years and years and years, and I keep hearing, "Oh, that's very nice, Howard, but it costs so much." And in this case, it doesn't.
No.
Yeah, that's great. So I think we're going to get into microclimates now, is it? Or
we're going to talk a bit about microclimate because that's a key factor
Yes.
in designing for any particular location. And we're going to let Charles talk a lot about how the DOE defines thermal comfort and what our response to that design criteria is. But I wanted to show you first just some interesting slides. I think this first one coming up, yes, this is a slide of the Big Island wind patterns. And I think of the trade winds as a moving stream, and the islands are like rocks in that stream. And when that moving stream of trade wind gets to the Big Island, that northeast direction is essentially gone after you get away from the windward side of the island. Our site is way up there at the top, where it says project site. I'm not sure if your viewers can reach it, but at that point, the winds have been modified to the point where they're coming almost due east. So we don't have a northeast wind to deal with anymore. We have primarily an eastern wind. When you're in Kona, they're coming from the south. It's like a turbulence pattern. So it's really quite intriguing. The next slide shows you just some of the data that we received from a small weather station, which is confirming the easterly direction on the lowest portion of the graph where you see the letter E. It's also confirming the average wind speeds, which are in the range of 7.5 to 10 miles an hour. And then in this final slide, before I let Charles take over, I wanted to show you some of the differences that occur just by being a short distance away. That big yellow arrow in the middle of the slide is pointing to the weather station that we use for our site, which is right below that. And then the other large arrow on the left-hand upper portion of the slide is pointing to the Upolu Airport. And between those two sites, which are only 3 miles away, our site has an average wind speed of about 7 or 8 miles an hour from the east, and the Upolu Airport has an average wind speed of about 21 miles an hour, and the wind is coming from the east-northeast. So 3 miles apart, incredibly different sites, and that's why it's so important to understand the microclimate.
yeah, we locals just sort of exult in our microclimates.
Yes.
Yeah. I live in the back of Manoa, and I like to say that I get about 120 inches of rain a year. Have a crow fly down from my place just 3 miles down to Waikiki, and you get about 20 inches of rain a year.
Yeah.
Yeah.
And the Big Island is the champion of all
Yes,
microclimates.
yes,
They have
yes.
many of them over there.
Yeah. Yeah.
All right, well, let's talk about thermal comfort a bit, if you'd be all right with that.
Yeah.
Yeah.
Sure. So I think the first thing that's very interesting as a designer, especially when it comes to passive design or passive cooling, is that there isn't really a code standard or code requirement, for thermal comfort, but there's many standards out there. And so it's up to the design team and the owner to establish what's going to be comfortable for the project. And I think the next slide we have up is, well, this is more on the wind. I think it's the one right after this one. Maybe one more. Well, sorry, we're still talking.
We'll come
about
back
the
to
wind.
these
Yeah,
slides.
we'll come back. Keep going. A few more slides, and you'll see what the DOE has established for thermal comfort, which is 80-degree effective temperature. And so what that means is that the DOE says, there you go, the DOE says that if you exceed 80 degrees in your classroom for more than a certain number of days, then you have to consider air conditioning. That's their definition of thermal comfort that we've used for this project. And the most interesting thing to me is, well, okay, Kohala, a great climate. We all discussed that it's nice and cool. You know, we shouldn't need air conditioning here. We shouldn't even need to consider it. But when you look at the hours of the school year, you can see that it actually exceeds 80 degrees effective temperature for a number of hours and a number of days. And it does require us then to look at mixed mode solution per the standard. So that kind of makes me think, well, actually, if we can't get there in Kohala, you know, it's unlikely that we'll be able to get there anywhere except for maybe, you know, top of Mauna Kea. So, you know, what DOE is asking us right now, in my opinion, is to consider mixed mode ventilation for all of our projects, right? And so that's where we start our design for this project here.
And for those who haven't heard that term before, it might be useful to let them know what mixed mode really means.
Sure, yeah. So mixed mode is a system where you can either operate in natural ventilation or passive cooling, where you're opening windows or using some other non-mechanical means of cooling for portions of the year when outside temperatures are thermally comfortable. And then other times of the year, you can use an air conditioning system. So what this does is it allows for two modes of operations in your building or more. And that's why it's called mixed mode, either a natural ventilation or a fully air conditioned solution.
And you know, Howard, we started out this entire discussion today based on the idea of what is passive design. And I'd just like to suggest that passive design is the key to both air conditioning mode and natural ventilation mode. Because if you don't have an efficient envelope to begin with, you're going to make bigger air conditioning equipment, or you're going to be uncomfortable when there is no air conditioning. So the whole dilemma, I guess you'd say, and maybe the challenge for us as designers, is to create buildings that function well under either scenario. And I think some of the problems DOE has had with its inventory, for example, is that some of the older buildings were designed reasonably well for air conditioning, but not so well for natural ventilation. And therefore, they don't have the option to go mixed mode as the newer facilities do.
Yeah. Well, one analogy I like to use is when you don't design to retard the solar gain, the heat coming through, and you air condition, you're putting an ice cube in an oven.
Yes,
Perfect.
that's a great,
Yeah.
that's a great analogy. Well,
So-
I'm sorry.
Oh, do we have some more slides to follow
Sure.
up on that?
Oh, why don't you go to the next graph after that, after the local climate.
A couple more slides.
Keep going.
Yep.
Okay, the next
We
one.
should
after
have
that.
one more. So what's interesting about a lot of the ways that a lot of people think about passive design or start their design is based on averages, right? So they say, oh, look at the average weather conditions. It seems too hot during this month, or it actually seems pretty nice throughout the year. And the challenge with that, or the concern that we have with that, is those averages also consider nighttime temperatures, right? So the most accurate way to do it, at least for a school, is to figure out the temperatures during the school year. And, you know, I should back up a little bit. The DOE talks about effective temperature, and I'm talking about temperature. And there's a lot of different definitions out there for temperature when we talk about thermal comfort. What's nice is that Farrar Choi has done a great job of shading the building and eliminating a lot of the radiant heat that factors into your thermal comfort. So typically, we like to think about thermal comfort in terms of both air temperature and radiant temperature. And those are the two that we have the most control over as designers, right? Clothing value, we don't really have too much control over that. Activity rate or MET rate, we don't really have too much control over that. That's up to the building. Humidity here, you know, we have some control over that in our air conditioning system. So when we talk about those two things, you can see that our air temperature is really what we can consider for thermal comfort in our space, because we blocked out all all the radiant temperature.
Is that what we're looking at in this graph, or?
Yeah, so the graph at the top is showing each month and the hour of the day. And what we did was we took all the hours of the year and we said, if we open the windows, what would be the temperature in this space? And would it be above or below that 80-degree threshold that the DOE says is our thermal comfort limit? And so there's a lot of blue in the morning, especially November, December, January, February, March. And then especially in the middle of the year and more particularly in the afternoon, those start to go to red. And so what that is telling us is we can't just say, oh, open your windows for the whole month, because that's what the average temperature says you can do. What it's telling us is we can use our windows for natural ventilation and passive cooling in the morning, but later on in the day, we might close it up, right? And that gives us a better feel for how the space might actually operate. So for instance, we don't want a teacher to have to come in the morning or stop the class in the middle of the day to shut the windows, and then at 3 o'clock or 4 o'clock or later on in the day open them back up. We want the space to be comfortable for that whole day or for that whole month, so it makes it easy for the occupants to operate the space and maximize the low energy passive cooling strategies that we've installed.
And I think the approach that we've taken based upon this particular site is that it's probably very comfortable and amenable to natural ventilation about half of the year. Other parts of the year it flexes a little bit, but the idea would be that there might be an air conditioning season and a natural ventilation season. So we'd put our system on a time clock, and from let's say November through April, the system would be non-air conditioned, and then from May through October, it would be air conditioned. But in either mode, there would be a manual override controlled very carefully by, let's say, the principal, that would allow them to turn the system either on or off depending upon unseasonable conditions.
Okay, let me throw in a concept which is part of your design, namely ceiling fans. What is the effect of ceiling fans on comfort level? And my instinct is that when those temperatures go above 80, they're not going a whole, in Kohala anyway, not going a whole heck of a lot above 80. And given that short delta, small delta T between 80 and whatever the discomfort level is, would ceiling fans take care of that?
Ceiling fans are extremely effective. And in particular, if your space is already moving the air, so you have air changes in that space, they're particularly effective. I think that Charles mentioned early on that there wasn't a specific number or code for thermal comfort, but they do have a calculator. So if you go to ASHRAE and you say to ASHRAE, my outdoor temperature is 83 degrees, my relative humidity is 75%, then it gives you things you can manipulate. And one of those things is airspeed, which is of course created by fans. As you increase that airspeed and you increase that sensation of air movement, the effective temperature starts to step downward. And depending upon which source you read, it either goes down like a degree for every 15 feet per minute to a half a degree to by 15 feet per minute. So you can feel much cooler. The analogy is a hot day here and stepping under a shady tree when there's a slight trade wind going. You think to yourself, geez, the temperature dropped 6 degrees. Well, it didn't really drop, but the lack of the radiant gain on your skin and the other conditions under the tree make you feel immediately cooler and much more comfortable.
And unfortunately, we're just getting warmed up on this topic and we have to leave. I will say that I have one of my favorite implements is a heat gun. And at one point on a hot summer day, I measured asphalt at 136 degrees, then went nearby under a tree and measured the grass in the shade, 86 degrees.
Yes.
40-degree delta T. So, we need to, when you get some specific measurements, we have to have you guys come back again, and we'll get down really into some nitty-gritty here.
You'd probably be reluctant to put your building right next to a hot asphalt parking lot then.
Absolutely, which is why I love this Kohala site so much.
Yeah.
I mean, it's really, really rural.
Yes. Yeah.
But on that cheery note, we need to bid fond farewell again. Howard Wigg, Code Green, my guests. Bill Brooks of Ferrero Choi and Charles Chaloeicheep of WSP Engineering, speaking about public schools and the vast improvement we're going to be making in those public schools. Thank you very much.
Thank you.